Hi, good day to everyone. Today I'm going to discuss to you the biomedical importance and therapeutic roles of activated charcoal. First, I would like to introduce myself. I am a professor of biochemistry and molecular biology as well as medical physiology at the Matthias H. Asnar Memorial College of Medicine here at Southwestern University in Cebu City. This is the oldest medical school in the central and southern Philippines, and we have operated this college for the past 66 years already. So now I am here as a professor of biochemistry, and I'm going to discuss to you the biomedical importance and therapeutic roles of activated charcoal. First, we'd like to emphasize to the audience or the hearing public that activated charcoal is categorized under a prophylactic or something like a cleansing agent that would remove toxins from the system. However, to some extent, because it is a biological material, there are some nutritive value. In my research, I was able to expound that this charcoal obtained from plant materials, especially the shells as well as cellulosic materials from plants, are basically polymers of carbohydrates and polysaccharides. In its nutrient content, we can account for about several components. Charcoal, in its origin, contains many pentoses. And pentoses, by definition, in biochemistry, it is a kind of 5-carbon sugar. And it has also some lignins. It's a kind of a polysaccharide. So this is about the pentoses, about 27% more or less. And there's about 29%. And cellulose is also found in, cellulose is also a polymer, it's a carbohydrate. Same is true with the cellulose. And then you have the uronic acids. It has 26.66%. You have the uronic acid about 3.5%. And of course the ash is about 0.6%. So if you try to take note, charcoal, although it is charred, however, it has some values because it contains pentoses, which is a 5-carbon sugar. It's a source of energy. Lignin is a carbohydrate, but these ones are the lignins and cellulose serves as adsorbents. That's why it's a very perfect material for detoxification in the human system. The uronic acids are also needed in metabolism. So these are derived from sugars. And of course the ash, and it has all the, not of nutritive value, but of what you call this, a cleansing value. So basically, if you're going to look at activated charcoal, it also contains some nutritive values, no? Or value. Now, for now, we are going to discuss what is really an activated carbon. So, an activated carbon looks like this when it is processed. It is basically a burned biological materials, and the perfect source of this are plant materials. So when you say activated carbon, it is also called the activated charcoal or activated coal, or you call it the carboactivatus. It's a form of carbon processed with several low or low volume pores that increases the surface area available for absorption or chemical reactions. So basically, it is a matrix that is provided in order to increase the surface area. You process it in different sizes so that the smaller the better, because the smaller the particles, the greater is the surface area. Therefore, the capacity to absorb rather, is a lot better compared to rough materials. So, before I could proceed, I would like to emphasize regarding carbon. All materials, whether it's plant or animal, when charred or burned, it is zeroed into an elemental form called carbon. And carbon, in the chemical point of view, it is an element with atomic number of 6. And this atomic number represents an atomic or electronic configuration that is responsible for the characteristic of this material. Now, since plant materials or animal materials, when charred, becomes carbon, so let us try to look at the chemical properties of this carbon. If you are going to arrange the electronic configurations of carbon having 6 electrons, then it would appear this way. So if this is the nucleus of the carbon, and the electrons are arranged around the nucleus, the first shell only accommodates 2 electrons, and that's already a pair of electrons. The succeeding shells, or the energy levels, can occupy at most 8 electrons. So since there are only 6 electrons in carbon, we could arrange it in this manner. 1, 2 in the first shell, and the second shell, or the second energy level, you have 1, 2, 3, 4, 5, 6. So all in all, there are 6 electrons because the atomic number of carbon is 6. So with this arrangement, the atomic level, carbon has a ligand, or you call it the valence. The other term for ligand is the valence, or its binding capacity. So in other words, carbon can bind at least 4 ligands because there is a vacant slot here. Now, why do you say so? Because electrons in nature should occur in pairs. But in this case, since they are not paired, so therefore there is vacancy in that slot. There's another vacancy in this slot, another vacancy in this slot, and in that slot. So in other words, carbon can accommodate a maximum of 4 ligands, or having the property of adsorbance. So that's why carbon has a very good adsorbance capacity. It's different from the word absorb because it is inside, but in this case, it's on the surface of the atom where molecules are attracted, or substances are attracted to. Now, carbon, compared to silicon, silicon as an element has atomic number of 14. So if you're going to arrange, so this is the nucleus of silicon, we can draw a electron configuration. So the first shell always occupies 2. So the second shell has a maximum of 8. So 1, 2, 3, 4, 5, 6, 7, 8. Oh, 9, 10. Then the outer shell, 11, 12, 13, 14. So if you're going to notice silicon in its electronic configuration and that of carbon, in its outer shell, they are the same, having a vacant slot of 1, 2, 3, 4. So that's why if you compare silicon with carbon, they have the same property in terms of adsorbance, meaning that silicon is also efficient in getting toxins from the system. But why is it that we cannot use silicon internally in removing toxins? You cannot just swallow silicon, or in the Tagalog word, silicon is actually buhangin. So you cannot eat buhangin, and you might complicate the system because silicon, although absorbent, but it is heavy, and it will complicate the gastrointestinal tract. So if you're going to make use of silicon as a adsorbing material for removing toxins, this is only good if it is applied outside the body. But you can never use this inside the body, much more in the gastrointestinal tract, because this might interfere with the absorbance of the nutrients in the small intestine. But carbon, you can actually tolerate the presence of carbon in the gastrointestinal tract because it is light, it is heavy, it is light, and therefore it does not settle, and they can always be they can form a what you call emulsifying properties of the food that we eat. So we don't advise the use of silicon for removing toxins in the human body. We only advise or recommend carbon, or as a source, or rather as an instrument or material for absorbing toxins in the human system. So basically, I even advise some patients that if they have some opportunities to go to the beach, you can, especially if the buhangin is clean or the sand is clean, you can dig a hole and then you bury yourself there with the sand. That is also a poultice. So that is also helpful practice. So it makes practical applications of this silicone as a material for removing toxins. You probably buried yourself in the sun for about 30 minutes to 1 hour. You have sufficient detoxification in that sense. But if you don't have the opportunity to have that, you can use carbon instead as your poultice. You can make a paste of carbon, activated carbon, and you can place it inside your, in the surface of your skin or all over the body to remove some form of toxins. So that's why this carbon evolved into a useful medical interventions for removing toxins from the outside. That's why it's called, the term here is poultice. No? So the term for that is poultice. So let's proceed with the discussion of activated carbon. So basically, when you say carbon, it is a charred material of living material, because the living materials are composed of carbons. Carbon skeletons marks the foundation of every organic substance. So if you are going to burn the organic substance, then it makes a carbon residue, which is now used as our interventions for the purpose of removing toxins. But in order to be guided on what type of carbon to be used properly in this intervention, we recommend only carbon from plant materials, especially those medicinal plants could be a very good source of carbon. But carbon, if it is not activated, has some form of less efficiency, or in other words, the efficiency of that carbon in terms of binding to some materials is less, because if they are not activated, then perhaps some contaminants are also bound to this surface. So in order to make it very efficient, it has to pass through what you call activation process. So what is activation of carbon? According to the definition of activation, it is actually the carbonization of the material using a range of temperature between 600 degrees to 900 degrees Celsius. The presence of this, subjecting it to this temperature would remove the contaminants of the carbon. So that if these contaminants of the carbon are removed, even gaseous materials or even what other materials, solid or liquid materials, are removed when the carbonized material is subjected to this temperature. So only materials that are subjected to this temperature will result to what you call activated carbon. And what is the advantage of this activated carbon? As I said, the efficiency of adsorbents is greater because once you activate it, that means there are no more contaminants. That means the carbon is already 100% efficient in terms of binding to the substances you want to remove. So that's on the physical activation. There is also what you call chemical activation. Chemical activation uses a lower temperature, about 450 to 900. So the physical activation is a lot better than chemical activation. So the source of carbon that we have mentioned earlier could be any material, could be a plant, could be an animal, could be inorganic, coal or whatever. But for our purpose of medical intervention, we recommend the carbon that is derived from plant materials, of which our activated charcoal that we have in this company, through the Actilife Health Products, we produce the activated carbon coming from plant materials. So that makes our product very safe. It is very excellent, as well as it's very efficient in removing toxins. So what is our, before I proceed to other aspects, well, let me just give you some classifications of carbon or activated carbons. One is that there is what we call a powdered activated carbon. These are actually traditionally active carbons that are made into particulate forms as small as the size of about 1 millimeter with an average diameter between about 0.15 as well as 0.25 millimeters. Now with this, if you are going to make a smaller size, then it has a large surface area. So this is what I have mentioned earlier, that the smaller the particles and the more activated it is, the better it is there for efficiency of removing toxins, as well as increasing the large surface area or increasing the surface area of a particular particulate matter. So mesh size matters. Then there is also what you call the granular activated carbon, or the GAC. This granular activated carbon has relatively larger particle size compared to powdered activated carbon. Therefore, presents a smaller surface area. So between the other carbon, this is a lot, or rather less efficient in terms of their adsorbent capacity. Then there is also the extruded activated carbon. This type of carbon combines a powdered activated carbon with a binder, which are fused together and extruded into cylindrical shapes that will measure to about 0.8 to about 130 millimeters. These are mainly used for gas phase applications in the industrial applications. So we don't use this type of extruded activated carbon for medical purposes. There is also the bead activated carbon. This is made from petroleum. This is not a good type. So I'm just reviewing to you some of these important carbons. The impregnated carbon are porous carbon containing several types of inorganic impregnated materials such as iodine. They use this for industrial purposes also. So in cleaning the water, for example, they use this because they are inorganic impregnations in the carbon such as iodine, silver, aluminum, manganese, zinc, iron, lithium, and calcium are incorporated. So drinking water can be obtained from natural water by